This is a problem from a grade 7 Singapore text, and students solve these problems in grade 7, whereas I've seen questions like this in high school and college algebra texts in the US. And in the US, we are taught to solve it symbolically or algebraically. We're going to first do it visually using bar diagrams or bar method, the Singapore style, and then we're going to solve it algebraically. And we're going to compare the two solutions. The ratio of the amount of turkey to the amount of chicken at the grocery store was 8:3. By the end of the day, 14 pounds of turkey had been sold. The ratio of the amount of turkey to the amount of chicken was now 3:2. How many pounds of turkey did the grocery store have in the morning? How many pounds of chicken did the grocery store have in the morning? Once again, it's a good idea to write down the question. However, the question will appear on every subsequent slide. So let's see how we can solve this problem. The ratio of the amount of turkey to the amount of chicken was 8:3 in the morning. So if I have 8 parts representing the turkey, I will have 3 identical parts representing the chicken. So each part could be 5 pounds, 10 pounds, we don't know. All we know is that for every 3 parts of chicken, I had 8 parts of turkey. That's all ratio tells us. Now, here's a question. They didn't sell any chicken, they sold turkey, and the new ratio is 3:2. So the amount of chicken originally was, the ratio of turkey to chicken originally was 8:3, and the new ratio of turkey to chicken is going to be 3:2. Now, we have to split the chicken into 2 parts as well. Otherwise, we won't be able to compare the two quantities visually. So what I'm going to do, and this is a crucial step, since the chicken didn't change, the total amount that will represent chicken, it's a good idea to choose it so that it's divisible by both 3 and 2. And once we see the solution, it should make a little more sense why we're doing it. So what I'm going to do is this. I want to take enough squares to represent chicken so that that total number of squares representing chicken is divisible by both 3 and 2. A good choice is 6. So now my original ratio of chicken to turkey is 3:8, and I still maintain that ratio, 3:8. So this is still a good representation of the original ratio. All I did is multiply 3 by 2, I got 6, multiplied 8 by 2, I got 16. So my old ratio still holds. So this is consistent, this is still 8:3. However, I can easily split the area that represents chicken into 2 parts fairly conveniently. Alright, so let's erase that. And this is a crucial step. You want to make sure you get this. However, they sold some of the turkey, so some of these little squares were gone. I don't know how many of the squares were gone. After they sold some turkey, the ratio of chicken to turkey was 3:2. That tells me for every 2 parts of chicken, they had 3 parts of turkey. That's what ratio means, and you want to get that. If you don't get the meaning of ratio, there is no way you will understand this problem. So by 3:2, we mean every 2 equal parts of chicken. For every 2 equal parts of chicken, we have 3 equal parts of turkey. So let's do it this way. I have 2 parts of chicken. I have 3 parts of turkey. I have 2 parts of chicken. I have 3 parts of turkey. I have 2 parts of chicken. I have 3 parts of turkey. Now that tells me nothing happened to chicken. Some of the turkey was sold. That tells me this was sold. Altogether, 7 of these chunks were sold. Only then, after everything is said and done, you will have the ratio of turkey to chicken will be 3:2. And nothing is happening to chicken. Now do you see why we had to, it's a good idea that we split into, we wanted to make sure the chicken area could have been split into 2 pieces. That's why I chose 3 by 2 rectangle or 6 squares to represent my chicken. Now, let's erase that. And you want to reflect on it a little bit before we move on. further. Let's erase everything. So we are claiming this was sold. If they sold this many parts of turkey, little squares, and they also sold 14 pounds of turkey. I have 7 squares here. So what does that mean? That means each square has to be worth 14 divided by 7 is equal to 2 pounds. So that tells me that each square has to be worth 2 pounds. This has to be 2, this has to be 2, this has to be 2, this has to be 2. You want to get that because they sold 7 squares and they sold 14 pounds. So you take your 14 pounds divided by 7 and you get 2. So what I'm going to do, this is really what they were left with. The darker shade of blue shows this is how much turkey they were left with. After they sold all this, this is how much chicken they were left with. We just discussed that each square should be worth 2. Now take a look at it. 2 plus 2 plus 2 plus 2 plus 2 plus 2 has to be 14. So all this is 2. Let's fill them up. 2, 2. Now this is the original scenario. Look at the ratio of this whole chicken is still 3 to 8. So for every 3 parts of chicken, you have 8 parts of turkey. For every 3 parts of chicken, you have 8 parts of turkey. Now, so the question is, how many pounds of turkey did they have originally? 32 pounds. There are 16 squares. Multiply 16 by 2, you're going to get 32. How many pounds of chicken did they have? Well, 2 times 6. Each square is worth 2 pounds. There are 6 squares. 6 times 2, 12. So these are your answers. They originally had 32 pounds of turkey and 12 pounds of chicken. So that's the visual method. Conceptual method, a method that helps us understand what is going on. And here's the one that's symbolic. Let's try the symbolic one now. Algebraic, symbolic, abstract, whatever term you want to use. So let's move on. Okay, because of this ratio, we're going to claim they had original ratio of turkey to chicken was 8 to 3. We're going to claim they had 8x pounds of turkey and 3x pounds of chicken. Because if you do that, you know, in ratio, sorry, let's erase that. Let's erase that. Kind of made a mistake here. Okay. If you have eight x to 3x is same as 8 to 3. That's the justification behind all this. So we're claiming that if you assume they had 8x pounds of chicken and 3x pounds of, if you assume they had 8x pounds of turkey and 3x pounds of chicken, it's consistent with our assumption regarding the ratio. Now, they sold some turkey and they sold 14 pounds of turkey. So by the end of the day, they had 8x minus 14 pounds of turkey, and they didn't sell any chicken, so they still have 3x pounds of chicken. Now, according to our question, the new ratio is 3 to 2, and the new amounts are 8x minus 14 and 3x. So we can set up our equation this way. 8x minus 14 divided by 3x is equal to 3 over 2. This comes from this ratio, and these two amounts are the new amounts. Now all we need to do is solve this algebraic equation. And we'll do it on the next slide. Well, we all know how to solve it. We cross multiply. right here, cross multiply, and then distribute 2 over 8x minus 14, and 3 times 3x is 9x. And then you move the variables on the same side. You get 16x minus 9x is equal to 28. 16x minus 9x is 7x is equal to 28. Divide both sides by, to find the value of x, divide both sides by 4. This should be 7. Okay, divide both sides by 7, you're going to get 4. This is 7. Okay, so x is 4. Okay, so if x is 4, how many pounds of turkey did they have originally? Originally they had 8x pounds of turkey. If x is 4, it's 32. And how many pounds of chicken did they have? They had 3x pounds of chicken, and if x is 4, 3 times 4 is 12. So you get the same answer as before, which is obvious. Why we shouldn't, I don't know why we shouldn't get the same answer. The idea here is that the visual one helps our students, younger students, understand the math behind what they do, and that's valuable. We want our students to learn the mathematics, not just follow steps without understanding to get a certain answer. And some of you want to do that, unfortunately, because you want to get to the answer, but you won't be able to apply that knowledge anywhere if you do that. If you just know how to get the answer and you just get it, and after the exam you're done with it. I know there are people like that, but as teachers we don't want that to happen. We want our students to understand the math and be able to use the math in the real world.